In this video, I'll be introducing the concept of RAG. What is RAG? Retrieval-Augmented Generation. Now, RAG is a very popular technique within AI that's used to search documents and essentially chat to your PDF files. So if you have a 200-page PDF or many 200-page PDFs and you've got a question to ask, all you have to do is type the question on the chat, and then the chat goes off and queries the documents and brings back the results in the format that you can use and easily consume. Welcome to the beginning of the series on RAG. So RAG stands for Retrieval Augmented Generation. So RAG is a technique within AI that's currently doing the rounds in many industries, and it's all about making your AI or your generative AI a lot more accurate, a lot more reliable, and very robust. Retrieval augmented generation is being utilized in the education space, in the medical space, and in normal other businesses like real estate and the legal world. And the typical use case is where people have large amounts of data and they need to be able to query that data in order to get useful information. So contracts in the legal space, 100-page contracts. Typically, you can use RAG within your AI space to send a question into your documents, and then something returns a result from all of your documentation. So rather than spending hours doing it, we get the machines to do all of that searching. So in this series, we'll go through RAG, what it means, and do some practical implementations of RAG, and hopefully we'll see the results and you can see the benefits it would have to your business or your normal everyday life. So so what is RAG? So RAG is a method used within AI that combines two powerful techniques. So within RAG, retrieval augmented generation. So there's retrieval side of things, and then there's the generation. And the retrieval is all about seeking out the information within from a collection of documents or a database. So if you had 500 files that contained useful information, you can chunk all of that information and save it in the database. And using RAG techniques, you can send a query, and that query goes in and searches through all of those documentations or all of those documents and returns a result. And then the generation aspect of RAG is used to convert whatever information has been returned into a natural language, into a language that you can easily understand, and treat it like the document is speaking back to you in normal grammar and normal text. So you have the retrieval side, and then you have the generation side. The retrieval is from information that's within the documents that you've saved, and then the generation talks to your AI model or any AI model to bring back the information in a creative way. So the retrieval part is like a librarian within a library. You can ask it a question, ask him or her a question, and she'll go off and find you the relevant books and find you the page where the content you're looking for could possibly exist. So that's what RAG is doing. So if you have a 100-page PDF file full of text, you can ask those questions, and in real time, it's able to respond to you based on the question you ask. And these documents tend to be chunked, that's divided into small portions and saved in a vector database. So when your question comes along, it finds the chunk that would answer the question that you've asked and then returns that chunk. When that chunk is returned to you, it's then used to query a large language model or small language model, which then converts that chunk into information that you can easily consume. So I've spoken about the retrieval. The generation bit is, whilst retrieval is bringing in all those chunks of text, this generation is the creative that will turn that into information that will be easy for you to consume and apply to whatever you want to use it for. So now, why does RAG exist? Now, one of the main purposes of RAG is to make sure that the information that the LLM is sending back to you is accurate and is reliable. Now, because you provide a chunk of text to the LLM, its responses will be based on that chunk of text you've given it. So that chunk of text, or the result from your query, is essentially the context within which the RAG system or the LLM system would respond to you. So it's not like your general questions that you'd ask ChatGPT, for instance, and ChatGPT will go off and could potentially hallucinate or come up with random answers. In the case of RAG, its context, or where it has to get the results from, is based on the chunks of data that you've sent through. So it makes it a lot more reliable and a lot less susceptible to hallucinations. So your typical use cases for RAG would be in customer service, for instance. Chatbots could be designed to respond based on RAG information. You've also got content marketing, where if you've got custom files or custom information, you could design your content to be generated based on the information within your documentation or within your knowledge base, and that knowledge base would determine how the content is constructed based on the prompts. And you can also make things a lot more personal because of the context within which your question will be answered. Then other areas where RAG comes in handy in healthcare for diagnosis. Essentially, if you think about where any question you're going to ask, if you've provided the entire context within which an answer should be returned, then in effect you're making it a lot more personal, and your options and the choices are essentially designed and mapped around what you've provided. So that's really one of the key benefits, and you can imagine how this can be used in the education sphere as well. Teaching kids, teaching children, you know that if they ask a question of your RAG system, then it's unlikely that it's going to pull information from the wrong source. The source will be the information you provide. So when I talk about context, it's really the source of the answers to your question. So let's have a look at a practical implementation of this, just a quick one, and over the next few days we'll look at some more. So this is a short deployment of it. In here, this is a notebook that's provided by Google. So this portal is provided by Google, but the code has been written in by myself. So at the beginning here, at the top here, we're just downloading the packages that will be needed to create the RAG environment, essentially. So this FAISS is used to simulate your vector database, and the vector database is where all those chunks of information that I mentioned earlier will be stored. And then the transformer is essentially the language model that would process the information that's been returned. So with that in place, we'll then look at the two categories in RAG that we've been discussing. So there's the retrieval and then there's the generation. So in here, in this retrieval section, I'm getting it to set up the documents. So this is a very quick example. So here you've got these three sentences, and they're simulating a different document. So in reality, these will be huge files that will form the document. And here the tokenizer and model, these are both being loaded. So the configurations for the tokenizer and the model are being loaded from this sentence transformer, which is a small model essentially. And from there, the tokenizer is what would convert these documents into tokens, essentially. Okay, and then we pass him some special tokens for padding or truncation of the sentences. So once this is done, the documents are embedded, and the embedding is essentially the saving of the text within the document into your database. So the information is indexed, i.e. saved, and that's where the retrieval would take place. So if I uncomment this section here, we should now be able to see what it looks like. So here I'm sending a query, what color is the sky, and we'll see what's retrieved. Bear in mind that the answers will come from these 3 sentences. Okay, so what's it saying? What color is the sky? That's a query I sent, and then what's retrieved is the sky is blue. So that's come from this one, right? So of the 3 sentences, that's the only one that's most appropriate. So that's the retrieval aspect. It's gone in, it's searched, it's come up with the best or the closest matching sentence. And then with regards to the generation of text, here, let's trigger this. So the sky is blue because, okay, so again, the prompt is the sky is blue. The model that is using is GPT-2, which is a fairly old one. You can use a newer model in our subsequent exercises. So the sky is blue because, so this is what we've sent into the LLM, and we're expecting a response. So it's saying the sky is blue because of the sun, right? So how has it formed that? So it's formed that from this here, the sun. So the sky is blue because of the sun. So it has essentially created a new sentence from the information that is received. So we sent in this prompt, the sky is blue because, and it's come back and said the sky is blue because of the sun. So it's gotten the sun aspect from the information we passed through, and it's created its own sentence. But it's also created some additional sentences here. So the sky is blue because of the moon, sky is blue because of the moon, sky is blue because of the stars. So there's a bit of tweaking that can be attached to this. So this is just giving you an example, an idea as to how this works. In reality, the index database would be a lot bigger. It's not going to be something small that you can utilize in a standard single notebook like I'm showing here. And there are a lot more techniques that we can attach to our queries to make sure that any information is coming strictly from what we want, and we can validate that information as well as part of the retrieval. So that's it for today. Do leave any comments in the comment section if you have further questions, and we're going to go even deeper into RAG as the days go by. So until next time, thank you very much for listening, and keep winning.